What if I told you that something thinner than a strand of hair is quietly holding our entire modern world together? Not steel,
Check
not
the
bolts,
viscosity on loop 3.
not welds, but tape,
Adjusting the flow
the
rate
kind
now.
you'll never
It's
notice,
stabilizing.
the kind that doesn't brag. But without it playing wind fly, cars would hold, and your phone, it would fall apart in your pocket. We use it to seal, to bond, to build, and never stop to ask, how is it made? Who makes it? And why is it so strong? Today, we peel back the layers, literally, from molten plastic to robotic arms, from invisible glue to the perfect paper cord. This is the story of how one of the most overlooked inventions of our time quietly became the backbone of everything. Let's begin. Tape that holds the world together. It doesn't sparkle. It doesn't make noise. It doesn't even have moving parts. But this quiet little strip of film is holding our world together, one bond at a time. In factories across America, engineers have replaced bolts and rivets with adhesive tape. Why? Because it's lighter, because it's faster, and because it works. Think about it. The dashboard in your car, held together with tape. The screen of your smartphone, tape. Even wind turbines, standing tall in remote deserts, use industrial adhesive tape to fasten internal components with surgical precision. And this isn't the kind of tape you pick up at the corner store. This tape is engineered, built molecule by molecule, to resist heat, pressure, moisture, and time. Yet despite its strength, it remains invisible to most of us, overlooked, underappreciated. But not today. Today, we're going to follow its journey. From tiny plastic pellets to a product strong enough to hold a jetliner panel in place at 30,000 feet. And it all begins with a substance you've heard of, but never really looked at twice. Let's meet the raw material behind the magic. Polypropylene. From oil to pellets, the birth of modern plastic. Before tape becomes tape, before it sticks, before it shines, it begins life in the most unexpected of places. Deep underground. Here, trapped beneath layers of rock and time, lie the raw ingredients of modern industry. Petroleum and natural gas. It's from these ancient remnants of life that we extract propylene, a colorless gas, light as air, but brimming with potential. In massive industrial reactors, propylene gas is combined with a powerful chemical catalyst. Under
Keep
high
the tension
pressure and
consistent
heat,
as you
roughly
smooth it down.
450 psi and 300 degrees Fahrenheit.
All right, this
Something
section looks
remarkable
good.
happens. The gas begins to link together, forming long, flexible chains. Chains we call polypropylene, a plastic that's lightweight, incredibly strong, and resistant to moisture. But you wouldn't recognize it yet. Not until it's cooled, stretched into spaghetti-like strands, and chopped into millions of tiny, uniform pieces, each one no larger than lemon. These little pellets, dull, beige, unremarkable, are the quiet heroes of this story. Each one is identical. Each one is pure. And together, they're ready to become something far greater than the sum of their parts. But before that can happen, they need to be dried. Because even a drop of water, even a single molecule of moisture, can ruin the clarity, strength, and structure of what comes next. And so, under careful heat, around 230 degrees Fahrenheit, these humble pellets are stripped of every trace of water, stabilized, and prepared for transformation. The question now is, how do you turn plastic grains into a film thinner than hair, yet stronger than steel? That's what we'll discover next. The art of creating the perfect film. Now that we have the perfect pellets, it's time to stretch them, literally, into something new, something delicate, something precise, something called film. Inside the heart of the factory, the pellets are poured into a heated chamber where they melt into a glowing, honey-like stream. This is no ordinary plastic suit. It's a carefully balanced mix of polymer and performance-enhancing additives, heat stabilizers to survive 500 degrees Fahrenheit, anti-static agents to repel dust, adhesion boosters to make glue stick like never before. From here, the molten plastic takes one of two very different journeys. The blown film method. Imagine blowing a giant bubble. Only this one is made of plastic. That's exactly what happens here. The hot resin is pushed through a circular die head and inflated from within by a blast of air, forming a thin, cylindrical balloon. As it rises, it stretches in every direction, lengthwise and sideways, making it strong in both axes. Cooling rings blast cold air from all sides, freezing the shape in seconds. Then, like pressing a balloon flat between two hands, rollers collapse into twin sheets of film, fusing them gently, preserving clarity and strength. It's graceful, it's fast, and it's used for millions of everyday applications. But it's not the only way. The cast film method. Instead of inflating plastic like a balloon, cast film pours it flat, like laying syrup on a cold metal plate. The molten resin flows through a narrow slit and lands on a chilled roller spinning at high speed. The contact cools the film instantly, locking in a mirror-smooth surface. Why does this matter? Because in industries where flatness and optical clarity are critical, like medical tapes or logo printing, cast film delivers near-perfect results. It's more precise, more consistent, more expensive, but when every micron matters, cast is king. Both methods, blown and cast, have their place. Some tapes need flexibility, others demand rigidity, some need strength, others clarity, but they all start here, with plastic transformed into a whisper-thin film, barely visible, yet engineered with purpose. And next, it's time to give that film its superpower, stickiness, the invisible power, coating the adhesive layer. So far, we built a perfect film, flat, flexible, virtually flawless, but without one crucial ingredient. It's just plastic. What gives tape its real power is what you can't see. The invisible, micron-thin layer of adhesive, engineered to bond instantly, hold tightly, and age gracefully, and applying it is an art in itself. Inside a sealed mixing tank, the adhesive is carefully prepared. Stir continuously to maintain a perfectly even texture. It could be water-based acrylic, chosen for its strength and resistance to heat, UV light, and time. Or it might be synthetic rubber, favored for its flexibility and lightning-fast tack across different surfaces. But either way, there's no margin for error, because this isn't a smear of glue. It's a layer no thicker than a human eyelash, applied with surgical precision by rollers and razor-sharp steel blades, down to the micron. Every inch must be perfect. If it's too thick, the tape becomes messy. Too thin, and it won't stick when it matters most. After coating, the film enters a heated drying chamber. Here, at 180 to 220 degrees Fahrenheit, any water or solvent evaporates, leaving behind a clear, smooth, and powerful adhesive surface. The result? A tape that bonds with confidence, sticks instantly, and stays strong for years without cracking, bubbling, or peeling. Some premium tapes go a step further, adding a second adhesive layer, tailored for special conditions, cold weather, high moisture, fragile materials. Because in the world of adhesive tape, performance isn't optional, it's engineered. And when that adhesive-coated film finally rolls out of the drying chamber, cool to the touch and gleaming like glass, it's ready for its next partner in this manufacturing dance. The humble paper core, an unsung hero that gives tape its spine. A dance of precision, winding the tape. Now comes the moment of truth. The film is coated, the core is ready, and it's time to bring them together. With precision measured in thousandths of an inch. This isn't just winding, it's choreography. Each paper core is loaded on the main spindle, either by hand or by robotic arms that move with mechanical grace. Laser alignment sensors check and recheck positioning to ensure the core is perfectly centered. 1 degree off, an entire roll could fail. On the opposite side, the adhesive-coated film unrolls from a massive reel. It's movement controlled by an electromagnetic brake that adjusts tension in real time. Too much tension, and the film stretches, warping the adhesive surface. Too little, and the roll loosens, vulnerable to peeling and failure. That's why every rotation is watched. By sensors, by software, by skilled eyes. A soft nip roller presses a film gently onto the spinning core, guiding the first bond. From there, the tape begins to wrap, layer after layer, at over 300 feet per minute. Yet, it's quiet, precise, like a dancer that never stumbles. As it winds, tiny jets of air sweep along the axis, blowing away microscopic dust, preventing bubbles and ensuring crystal clear edges. Every few seconds, thickness sensors scan the roller, checking for any deviation. If the edge drifts more than 0.01 inches, the system corrects instantly. At full speed, these machines can complete hundreds of rolls an hour, yet no two are exactly alike. That's where human expertise still shines. There's a feel to it, says one technician. You listen to the rollers, you watch the edges, you know when something's off, even before the sensors catch it. When a roll reaches its final diameter, an automatic blade slices the film clean. A thermal roller seals the edge. And just like that, a finished roll of tape slides onto conveyor. Cool, tight, and ready. Behind it, a fresh core is already in place. The dance continues, flawless, relentless. And while the machines hum on, each roll moves forward into its final test. Inspection, packaging, and the long journey ahead. Closing the loop, inspect, package, and ship. A finished roll of tape might look simple, but before it ever leaves a factory, it must pass one final gauntlet, the inspection zone. Here, nothing is left to chance. High-resolution industrial cameras scan the entire surface of each roll, looking for flaws invisible to the human eye. Crossmark edge misalignment, crossmark uneven winding, crossmark dust particles in the adhesive. Compression sensors check the tightness, ensuring tension is distributed evenly from the paper core to the film's outermost layer. If anything is off, even by a hair, the roll is flagged, separated, rewound, or recycled. Because when a product is used in aerospace, medical, or industrial settings, there is no room for error. Once a roll passes inspection, it moves on to dimension checks. Its weight, its width, its adhesive type. Then comes the label precise, automatic traceable. Some factories even add QR codes, allowing clients to track each roll from production to packaging performance in the field. Before packaging, a soft press roller smooths out the final layer, releasing any trapped air, sealing the surface. Then, the roll is wrapped in a PE shrink film, guarding from humidity, dust, and mechanical impact. And here's a poetic twist. The cartons used to ship these rolls, they're sealed using the very tape they contain. Tape sealing tape. A perfect loop. Finally, robotic arms stack rolls into cartons or trays. 36, 72, even 100 at a time, before shrink wrapping entire pallets, labeling them with barcodes, and rolling them into the dispatch zone. Each box has a destination. Each pallet a purpose. Construction sites in Texas. Electronics factories in Taiwan. Medical labs in Germany. From this one factory floor, the world connects. But before the trucks pull away, before the loading doors close, a new batch of pellets is already melting, already transformed, because the story doesn't end here. More than just tape, the silent force behind progress. We started with plastic pellets. Simple, small, unassuming, and we followed their journey through fire and pressure, through precision and patience, through machines that never sleep and hands that never rust. And now, we see what they've become. Not just tape, but trust. Trust that the parts of an airplane will stay bonded at 30,000 feet. Trust that your heart monitor will stay intact through the night. Trust that the shipment holding your medicine, your groceries, your memories arrives sealed and safe. This isn't just manufacturing. This is craftsmanship at scale. It's the quiet, steady force behind every modern convenience we take for granted. And perhaps that's the point. Because the best inventions, they don't need to shout. They simply do their job perfectly, again and again. So the next time you tear off a strip of tape, pause, look closer. You're holding a product of chemistry, engineering, and human ingenuity, woven into one humble, invisible tool. And if this much thought goes into tape, just imagine the stories behind the other things we use every single day. Which everyday product would you like to explore next? Tell us in the comments. We love to dive in. And don't forget to subscribe so you never miss the invisible stories that hold our world together, one inch at a time.